Dear students, this lesson we're going to focus on formula. We're going to see how to use a formula and how to make subject of the formula. First of all, we use formulas to generalize when we need something and to be efficient. For example, we have a formula for the area of a square, of a rectangle, of a circle. We use those formulas instead of each time trying to find a formula to be able to work it out. So, formulas are used to be able to generalize. First of all, in this first part of the lesson, we're going to see different formulas and we're going to use them to solve simple problems. For example, first of all, we can substitute values into formulas. For example, if A is 2, B is 6, H is 10, find the value of A if A is equal to HA plus B on 2. You might be familiar with this formula. That is the formula for the area of a trapezium. So what do we need to do? We need to substitute A, B, and C and H, into that formula. And we get the following. A equals H, which is 10, times A plus B, 2 plus 6, on 2. And we can then work that out. So it's 80 on 2, so that is 40. Let's see another example. Find the value of S when U equals 10, T equals 5, A equals 10, in S equals UT plus 1/2 AT squared. Again, that's a formula which some of you might be familiar with. It's used in physics, in linear motion. So we get S equals U times T plus 1/2 times A times T squared. We work out this and we get 175. So we have seen that when we have a formula and we have values, we can simply substitute values into that formula to get a result. That result many times means something. But many times we need to make subject of the formula before continuing to work out our problem. So, subject of the formula. There are various formulas. Some of them are very easy, some of them are more complicated, and to make a subject of the formula sometimes it's going to take a long way. Sometimes it's just one step, 2 steps, or many steps. I'm going to start from easy problems and then continue to harder problems. Each time I'm going to make X subject of the formula. So in our formulas, there's always an X, there's going to be an X, and X is going to be the subject, our subject. So let's find the first formula, write the first formula. So example number 1, Y is equal to AX. I need to make X subject. So I decide that I need to remove the A, which is being multiplied by X. So the operation is multiplication. If I remove A, I have to inverse that operation, and the inverse of multiplication is division. So X is equal to Y all over A, and that's the result. That's a one-step problem. Example number 2. y equals ax plus b. Now we have two variables which I have to remove to leave x, and these are a and plus b. Now we have to work the inverse of BODMAS. So if it's brackets, indices, division, multiplication, addition and subtraction, we start from the last. So addition and subtraction have to be removed first in this case. So I have plus b, which is going to be moved to the other side. The operation is plus, so I'm going to subtract. So y minus b is equal to ax. Now I'm going to remove a, same thing as we did here. So x equals y minus b divided by a. And that is our second example. Our third example. Y equals ax plus b on c. This time we also have division, so we have to be very careful. If our subject is not in the denominator, as in this case, we remove the c first, all right? We remove the denominator first. Now, c is dividing, so place it on the other side of the equation. From division, it will become times. Remember that this time we have to remove three variables, a plus b and c, and we're going to start from c. So yc is equal to ax plus b. Now the problem is the same as the other one. I'm going to remove b first and then a. So yc minus b is equal to ax. So x is equal to yc minus b on a. And that is our third example. Sometimes our examples might be a little bit harder. For example, number 4. ax plus b equals cx. And we need to make x subject of the formula. Now we have got a problem. Our problem is that we've got an x here and an x there. So when we have more than one of that subject, first step, we need to place all the terms with that subject on one side of the equation. So I'm going to leave ax where it is. I'm going to bring cx to the other side. That's plus, so it's minus. B to the other side from positive to negative. Now, since I have two x's and there are two terms in x, x is a common factor. So taking out x as a common factor, I'm left with a minus c on this side of the equation. X is the common factor, leaving a minus c is equal to minus b. Now, removing a minus c, brackets means multiplication. We've seen this before. Removing a minus c, so x equals minus b all over a minus c. And that's our fourth example. Our fifth example. We've got a into x plus b is equal to c into x plus d. This time, our subject is also multiple. There are many terms there, two terms which have an x, and they are inside the bracket. So the first step is that we need to open up that bracket. We need to expand the bracket. So ax multiplying x plus b by a, I get ax plus ab. Multiplying x plus d by c, I get cx plus cd. Now, I'm going to place all the terms with x on one side and the others on the other side. So ax plus cx equals, minus cx equals cd minus ab. Now, removing x by common factor, taking out x, I get a minus c equals cd minus ab. So x is equal to cd minus ab all over a minus c. And that is our final result. Now, for those of you sitting for paper B, that's the most complicated problem which you might have. I'm going to do some more examples. still you have to pay attention for these examples because you might never know, but for paper students these examples make a little bit more sense. So again, it's always x that we need to make subject of the formula, and this is an example. We've arrived at number 5, so this is number 6. Example number 6. Ax squared equals b. This can also come out in paper B, so please pay attention. So I have the following. X squared is equal, I'm going to remove a first, because in this is our last. I'm going to remove a, multiply, so it's divide, b on a. Now I need to remove the square. Square is a very important operation. What does it mean? It means that I am multiplying by itself, so I have a number which when multiplied by itself gives b on a. So the inverse of square is plus or minus square root. That plus or minus is very important, so please pay attention. Okay? When you're told to find a value of something which is squared, if you're not told that it is positive or negative directly, it means that it has to be either positive or negative. So you have to write them both. Let's make another example. Example number 7. Ax squared plus bx squared equals c squared. I need to make x subject of the formula. First of all, I'm going to take out x squared as a common factor. Taking out x squared, I get a plus b equals c squared. So x squared is c squared all over a plus b. Same thing as in the other equation, x is equal to plus or minus the square root of c squared all over a plus b. Or you can write it down, same thing as plus or minus c on square root a plus b. It's the same, that is the same result. I have rooted the c squared. Last example, example number 8. T equals 1 on 2 pi square root x on g. And I need x as a subject. Now I'm going to start by removing this 2 pi here. I'm going to place it on the other side. It's dividing, so I have 2 pi t is square root x on g. I'm going to remove the square root. On the other side it becomes a square. So I have 2 pi t squared is x on g. So x is equal to g times 2 pi t squared. I can square that bracket, which I get 4 pi squared gt squared equals x. And there I have x as a subject of the formula. So that's about subject of the formula. Thanks for your attention.